Welcome, everyone, and thank you for joining us today in this webinar. We are very excited to have you here with us in this live session. In this webinar, you will discover how Antenna Magus simplifies your antenna design from navigating a specification-based workflow to creating and tweaking designs from 5G and other applications, exporting fully parametrics model to CST Studio Suite and optimizing performance with array synthesis and built-in utilities. Our presenter today is Ismari Lavandera, Senior Technical Sales Engineer at Bias 3D. She brings over 13 years of experience in RF and microwave systems, as well as electromagnetic simulation. Her deep technical background and hands-on expertise make her perfect guide for this session. Without further ado, it's my pleasure to hand it over to you, Ismari. Thank you for being here.
Thank you, Manuel, for the presentation, and welcome everyone. And thanks for joining today's webinar. So today we will explore how to simplify antenna design using Antenna Magus. So let's begin by looking at what we will cover, okay? So here's a quick overview of today's agenda. We will start by discussing the challenges in antenna design, then walk through the Antenna Magus workflow and highlight its key advantage. I will also share this an example toward the end. We will follow up by a question and answer session. Okay. So to understand the value of Antenna Magus, it is important to first recognize the challenges engineers face in antenna design. Let's take a closer look at some of these pain points. Antenna design is highly specialized and complex process that requires deep domain expertise. A successful design must deliver antenna element that is not only high performing, but also robust and against manufacturing tolerance and cost effective to products. Designers face the challenges of balancing multiple performance parameters, such gain, bandwidth, etc., while ensuring the antenna integrates seamlessly with the overall system. So making the right decision um, early in the development cycle, it is critical to avoid costly redesign, delays, and budget overruns. Traditional methods like adapting existing designs or searching through textbooks and academic papers are no longer efficient or reliable for identifying the ultimate solution. Additionally, the increased demands for regulatory compliance, simulation accuracy, and design scalability adds further complexity to the workflow. So let me give you a quick example. For example, in our automotive radar system, even a small deviation in antenna performance can affect object detection accuracy. So these challenges don't just affect performance, they also impact development time, cost, and regulatory approval. So this challenge highlights the need for intelligent design tools like Antenna Magus, which streamline the selection process, reduce risk, and empower engineers to explore a wide range of validated antenna topologies quickly and confidently. So now that we've seen the challenges, let's explore how Antenna Magus address them through a streamlined workflow, from finding the right antenna to exporting to a simulation-ready model. Antenna Magus provide the capability to design and evaluate over more than 350 antenna and array types, concise and accessible information about different antenna and topics, including reference to relevant literature and research resources, as well as many useful tools and libraries and exportable accurate simulation models are also included, making Antenna Magus an extremely powerful and flexible design tool for anyone working with with antennas. As you can see on the workflow process, just simple 4 steps, we can say that. So finding antenna, specification user with an extensive library of antenna, then you can design and tweak the designs with a useful design guidelines that we will talk about on the next slides. Evaluate and compare quick evaluation of the antenna performance KPIs, and later you can export to CST model. Or there is another tool that is FECO. Also, you can export FECO files. So compared to traditional workflow that rely on manual calculation or fragmented tools, Antenna Magus offers a unified and intuitive process. This workflow is specifically helpful for teams working across disciplines. RF engineers, mechanical designer, and system integrator and all benefit from this tool. Okay. So one of the standout features of Antenna Magus, it is design flexibility. Let's dive into how the tool simplifies antenna selection and specification-based workflow. The design's capabilities offered by Antenna Magus are the most flexible of all commercial antenna designs tools, from the quick start page to the specification user aids the user in selecting an appropriate standard specification or defining a new specification. In the case where a specification is not desired, the antenna library can be accessed by selecting define antenna mode, as you can see on top. As you can see, so once a specification is selected, the user is directed to the familiar find mode page that we will see in the next slide. If you notice, there is a tab that it says design here. This green check is an indicator where an associated design exists for the specifications. The specification chooser is particularly useful for new engineers of those unfamiliar with antenna design. It will guide you through the selection of process based on performance needs. This feature reduces the guesswork and helps ensure that the antenna meets system level requirement from the start. So let us talk a little bit about that. So building on that, let us look at how a specification-based design helps speed up development by offering practical, ready-to-use prototype tailored to specific a scenario. In fine mode, the active specification will be shown in the palette. In the selected specification, candidates prototype have been included, also known as specification-based design. This static antenna design takes in situ operations into account and thus speed up the development of standard design as an integrated devices. Therefore, by optimizing for a particular scenario, a specification-based design offers practically at the expense of practicality, at the expense of flexibility. Once a specification has been selected, any available specification-based design will be listed first in the find mode workspace, as you can see here in green. Once you choose the prototype that is not a specification-based design, then you can continue to evaluate the design, like these other examples that you see on the bottom here. So at the end, specification-based design are great when you need a quick prototype that is already optimized for a specific scenario, like a low-profile antenna for a drone and other examples. This saves time and allows you to focus on integration and testing rather than starting from scratch. Okay. So once you have found and add antennas that may be suitable for your application to the collection, Antenna Magus can help design them to meet your electrical specification. The overview in the main window of the antenna aims to provide a summary of the devices, so all is designed. Once an antenna has been designed by Antenna Magus, its performance can be estimated. So at the end, you can compare the physical size or performance between designs of different devices types and choose the design that you are going to implement. I recommend adding multiple antennas to your collection and comparing their KPIs. This helps you make a confident decision. This step is crucial before moving to simulation, and it helps avoid unnecessary iteration and prototyping. So we will see an example later. After evaluation, exporting the design to CST Studio Suite or other tools is seamless. Let's see how Antenna Magus ensure that the export models are accurate and parametric. An alter FECO or CST Studio Suite model of any antenna can be exported by Antenna Magus. These models are completely parametric for the dimensions indicated in the Antenna Magus documentation. They have also been validated against results available in literature and tested to ensure that they evaluate correctly for a wide variation of parameters. When we say parametric, we mean that the model can be easily adjusted. Dimensions, material, and other parameters can be changed without rebuilding all the geometry. This is a huge time saver when you need to run multiple simulations or optimize for different constraints. Okay. So to bring everything together, let me walk you through a design example of an X-band patch antenna. This will show how the workflow and feature we discussed come into play in a real-world scenario. I choose the X-band patch antenna because it is commonly used in radar and satellite communication, and it is a great example of how Antenna Magus simplifies the design process. In these examples, I focus on optimizing bandwidth while keeping the size compact. Okay, so let us start for the video. So as you can see, you will see the GUI directly when you open Antenna Magus. Then you go to the specification for radar, and then select the X-band radar, which we have there. So once you click there, it will show up all the complete GUI with all information. As you can see, the values for those X-band and the keywords used for X-band. And if you can see these two that you show here are the specific base design example, which we cannot modify too much. And since the objective to show you how the models could be, let us start from designing. And we have this specification user that is a good factor point here that we have here, 0.98. So we start the design, and I would just estimate the performance. This is an overview of the complete model that we are using, and I will estimate the performance the way that it is. And so I will get some information of some parameter like impedance, far field, all of that, all of those parameters. Okay, as we can see here. So I will show we go to the tab of estimate performance and select between reflection, coefficient. If you see the impedance there is 72, so this design was designed for 70. And for my specific system, I want 50 ohms. So I want to see how it would look like the reflection coefficient. So it seems that I need to improve a little bit the matching of my antenna. So I'm checking the VSWR, the impedance, reflection coefficient. But let us create a new design that to improve my parameters, to improve my variables. So this design, I want to add a real material, a physical real material that is commercial. For example, I will go to Roger, but if you can see the substrate is telling me that relative permittivity, it should be below this value. So it will give me recommendations. So I will go through another value and see if there is another from the same company, Reuters, to see some low relative permittivity. And I choose this one. I'm just choosing this one because I want to show you what the message that I will get from Antenna Magus when I design. If you see, I get this warning, tell me, okay, this is outside of the range. Please use a thicker substrate. So I choose one with 1.5 and I do the design. But if you see, I'm getting several bandwidth here, but I am focusing from at least 9 to 11 gigahertz. So I need to improve on that bandwidth. I need to get more best performance. So for that, I check the information and the recommendations that it give me, and then I start a new tweak. With this tweak, I can modify the variables. For example, in this case, this is the slot, how much the slot dimension is, how thick the slot is. So I'm increasing this value. And if you see, I kind of get a better performance at the range of the frequencies that I'm going to design. But still, I want to improve it. I want to get better performance. So I will create a new tweak. So I just want to show you how all the steps. I know that I should decrease a little bit this value here of the width. As you can see on top there on the overview, how we can decrease this slot width. And also I know that according to the description here on the information, that decreasing the slot angle, it will decrease it will affect the bandwidth. So I will be changing to the value, minimum value, because it is recommended should be between 22 and 30. And with that, I will estimate the new performance of my antenna. So if we check the estimate performance, if you see there is an improvement compared to the first one, to the second one, sorry. And based on that, okay, I already have my design as I am expecting. You can check other parameters if you want, but I'm just concentrating on the bandwidth on this case. And I just go to export the model. If you see everything is there, all the parameters, reference, I will save the expand patch antenna on the CST format. And then I will go to CST, open the project, and you can see it is completely parameterized, and you will see these anchor points here that you see on the post on all the sites. This will help me to place the antenna in any other platform that I need to put it. So it will help me for everything. If you see that all the setup, it is already, and also the far field monitors are all set up. So I just run the simulation and I will get the results, which are kind of similar to what I got from Antenna Magus, as you can see on the S parameter representation. So it seems it is not too complicated, to be honest. It's kind of easy if you think about what all the process that you have to follow when you are designing the old way, designing an antenna. You have to go through the box, check the equations, check the system. Here is already giving you some recommendation. My like tips: check the width, check the slot angle, check this, and it will improve this parameter. So, and also at the end on CST, you can change everything because everything is already parameterized. So let us continue with the next slide. So beyond single antennas, Antenna Magus also support array synthesis. This is especially useful for applications requiring beamforming or specific gradation patterns. So the array synthesis tool is in Antenna Magus assist engineers in the design analysis of antenna array of different shape and size. The tool includes the ability to synthesize typical array layout and excitation distribution for objectives like gain, beam width, screen angle, silo levels. User can import externally defined layouts and specify 3D patterns, individual elements. So array layouts and synthesis 3D array patterns can be exported in various formats for use in further simulation. As you can see, all these different type of array performance, so you can have and export later. So here's a deeper look at how array layouts and excitation distribution can be customized and export for further analysis. You can see it is already created this type of array, circular array with this configuration like cylindrical. And then you export the physical array. It will export a CSV file, TSV file. And with the help of CST, sometimes in CST, you cannot create a specific array layout because it is not considered in CST, but just bringing this TSV file, it will help you to create this kind of form in CST. So it's very useful feature that we have on Antenna Magus to implement in our ordinary work. So now, Antenna Magus it is more than just a database of antenna. It is also a toolbox for antenna engineers full of useful utilities and libraries that can be used to simplify everyday antenna tasks. So let's explore some of these utility. As you can see, the toolbox contains a collection of useful tools and utilities for antenna designer. These tools include system calculators, approximation tool, data conversion tools, and many others. For example, the chart tracer. So any scan graph image using the mouse and export is a format text data. You can also calculate the required gain or receive antenna using Frest calculator and many more. So additionally, Antenna Magus has integrated libraries for a number of materials and components. Uh, this library simplify finding commercial standard substrate, as we saw on the example before. Waveguides, connectors, whilst the Redom library contain also a number of most popular aerodynamic nose cone shapes, so you can verify that. Substrate in the substrate library may be used when designing antenna and Antenna Magus. So my recommendation, please just check it. Go if you have Antenna Magus, just go ahead and try and check all the options that you will have there. It will be help you to improve all your connection. The same way that ECMI connector, all the connector, sometimes we don't know, or you have to create from zero the connector on CST. You can bring the connector, the commercial connector from here to CST. And that will be improve and speed up your simulation time, okay? So that wraps up the main contents. I would love to hear your question or comments. So please feel free to share them now. So, Manuel, do you have any comments on the question and answer?
I don't think we have any question yet. Let's give it a couple of minutes.
Sure.
Yeah.
I'm seeing a question on the comments or
Okay, here's one question. Can I use dielectrics in the design?
yes, you can use the electric in design. As I already show an example, you can bring commercial dielectrics even to for any design. Depending of the design can have this dielectric, of course. But yes, you can use it.
All right, here's another question.
Mhm.
Can I create an assembly of antennas in Antenna Magus, or do I have to do it in CST?
I don't think that is possible. You have to, there are certain models on Antenna Magus. Then you have the model. You can modify the model, the variable of the model, and then you can bring that to CST. And then later in CST, you can assemble with a platform or wherever is the system that you are connecting to, you can do that on CST.
All right, thank you. Seems like we don't have no more further questions. So we do encourage you, in case you have any other question, please reach out to us. Here's this email contact, and we will be sharing or all of the information to buy S3D, so you can be in touch with us. And thank you so much for attending. Thank you so much, Smari, for this great presentation. And yeah, have a great day.
Thank you all for attending today's sessions.